All right, so today we're going to talk about a geometric sequence. We've already talked about arithmetic sequence. Remember, a sequence is just a list of terms, and arithmetic was we had to add to get from term to term. And you can probably figure out that geometric means we're probably going to do something slightly different. It's still a list of numbers, though, where the next term is calculated by multiplying by a certain number. It could be a fraction. It could be a big number. You never know. But basically, that's how we're going to get from term to term is by multiplying by something this time. And then what we multiply by is basically called the common ratio, and we're going to call it R for in our formulas. Just like in arithmetic, we use D for difference. So basically, this is whatever it is you're going to multiply by to get from term to term. So maybe it's 5, maybe it's 1/3. Who knows? Depends on each problem. You have to try and figure that out. Okay. So to calculate the next two terms, it's probably going to be very helpful to figure out what is R. Now, on some problems, it's going to be pretty easy to figure out because here, obviously, our first term is 4, and then we go to 16, and then 64. That's pretty straightforward to see that R is 4. If you ever get stuck, though, just take one term and divide it by the previous term. So in this case, it'd be 16 divided by 4. That will tell you what R is going to be in case they get a little bit more complicated. So if I want just the next two terms, well, obviously, this is a sub 1, a sub 2, a sub 3. All you need to find is a sub 4 and a sub 5. And so if we take 64 times 4, that's getting a little bit bigger, 256. And then times 4 again is 1,024. Okay? And that's all you would need to do in those particular cases. Now letter B, seeing the numbers are going down, obviously is going to be a little bit more complicated. But once again, you're probably going to want to figure out R first. So if you can't tell this one, this is definitely a case where maybe you might be slightly confused. So take one term and divide it by the previous term. So 27 divided by 81. Obviously, we're not going to leave it like that. And it happens to work out quite nicely that 27 goes into there once, goes into there 3 times. So R is 1/3. So it's kind of like when we had negatives with arithmetic. That's how they basically go down. And so these numbers are probably going to get smaller. So there's a sub 1, a sub 2, a sub 3. So we got to find, again, a sub 4 and a sub 5. So if you take 9 times 1/3, it's almost like dividing by 3 is really what it's doing. And so the next term is 3 followed by 1. Well, obviously in the previous examples, we only had to go a couple terms out, so it wasn't too difficult. But once again, what if I gave you the first term and I wanted the 100th term? You're probably not going to want to sit there and multiply it out 100 times, or actually 99 times. So we have two formulas. I believe that one of them is much more helpful than the other. This one here is basically the one we were just using. Take the previous term and multiply it by R, and then it'll give you the next term. Well, that's pretty easy. That's not going to help you if you want the 100th term. This is the one that's probably going to prove much more helpful because, again, you see the n in there, and you can plug in any term you want. Maybe you want the 50th term, or maybe it is just the 6th term, and you don't want to multiply it out. Either way works. But notice this one does use the first term, where the other formula does not. And so this lets you go wherever you want to in that particular sequence and pick any particular term. So notice I put the formula up there, the one that's going to be more helpful. So here it says, right, the first 4 terms of each one. Well, I'm not sure we would necessarily have to use that formula for this particular one, because if all we have is the first term and we need 4, well, the second term, well, that's pretty easy to figure out. Well, is it 7? Because you're adding 3? No, we're multiplying by 3. So the next term is going to be 12. So in this formula, basically all you have to do is keep multiplying. And I said, what, first 4 terms? So let's get the next couple out there. So 36 and 108. So to use that formula up above is if they would have asked me in this problem, not for the first 4, but say maybe they asked me for the 20th term, then we would have used that. Why don't you take a second and try letter B right now on your own. Well, possibly one of the things that could have thrown you off here is that R is negative. And that's fine. You can multiply by a negative. That's not necessarily the end of the world. We can do that. And so obviously our first term is 125. Second, so we need the first 4. So once again, this formula up there in the left corner, top left corner, probably not as helpful. So you multiply by a negative 2/5. Be careful on that when you do that, and you get negative 50 for the second term. Negative 2/5 again is a positive 20 because it's a negative times a negative. And times negative 2/5 again is negative 8. If I keep going, obviously these numbers are going to turn into fractions. Remember, improper fractions are just fine, but make sure you have them simplified. Just to help you out a little bit on these problems, why don't we take letter A and kind of have a sub 2 or something like that is what you could call it. And we'll say that a sub 1 is 4. We'll still say r is 3, but I'm going to change it. I'm going to say let's go ahead and say find the 20th term. Well, I know we're already out to the 4th term, but that would still be a lot of multiplying for us to get out to the 20th term. And I hope you can see that this number is probably going to get pretty big. Okay? It's not going to be necessarily the smallest number in the world. So what you're going to do is, well, I want to find, as you can see up there, I want to find the 20th term, so that would be a sub 20. That's what n is, 20. So a sub 1 is 4, and r is 3, and n is 20. So it'd be 20 minus 1 power. Again, I'm plugging it right into that formula there. So in other words, it's 3 to the 19th power. Now, if you do order of operations, what you have to do is take 3 to the 19th power and then take it times 4. So why don't you go ahead and do that right now. And remember to take it to the 19th power, you might have used the caret key. And what I got is so a nice small number there for the 20th term, 4 billion. So that's definitely one where you wouldn't want to write out all 20 terms to find it. And that's where you could use that formula on the top left. But knowing when to use it and when not to use it is really important. So on these A and B that we started with, probably don't need it. This one here, very helpful. So let's decide if we need that formula. Here they say determine the nth term. So I'm basically wanting to find the 5th term. They have given me the 4th term and what to multiply by. I would suggest that maybe using that formula is not all that helpful because basically you're already sitting out at the 4th term, and all you need is the 5th term, which would be next. So we don't even need to know the 3rd, 2nd, or 1st term in this one because they just told me the 4th one. And so you just go ahead and multiply by 1/2, and the 5th term is just 5. Just a coincidence that the 5th term is 5. So you have to decide here, well, they've given me the 6th, they want the 9th, and I know I have to multiply by 3. Well, that's not really all that far away either, because all you'd have to find is the 7th, then the 8th, and then the 9th. So that's really not that bad either. So I would suggest maybe not using it for that one either. So we go 5 times 3, well, that's 15. Times 3, what do we got there is 45. And times 3 again is 135. So the 9th term is 135. Okay. So keep in mind when to use it and when not to. Probably when the distance is a long ways away, maybe more than 3 or 4 terms, that's when maybe you're going to use that formula. It'll help you get there quicker than writing every single term out. The example 4 that you have on your notes, you can scribble off and replace it with this one. I'll give you a second to write this one down. All right, before we had, we had arithmetic means, which meant, we had to find, basically get there by adding, and here's geometric means, which means we have to get there by multiplying. So really what the question is saying is if I had 2 sitting right here and then I had 1, 2, 3 blanks in between, how would you get to 162? And they're telling us it's geometric. So I have to figure out how would I multiply by the same number every time and get there. Well, I'm guessing the number's really probably not that big if I have to only multiply that many times. But you could look at it as this is a sub 1, so this would be a sub 2, a sub 3, a sub 4, and then a sub 5 is how you could look at that. And so here's where that formula could prove to be very helpful. So a sub n is 162. Okay. A sub 1 is 2. R I don't know. And, well, how many terms are there? Well, there's 1, 2, 3, 4, 5 terms total, so it'd be 5 minus 1 would be your exponent. And so we know that to be the 4th power. Now, when solving this, the 2 is probably causing the most difficulty, so divide by 2 to get it out of there. Okay. And so these cancel. And so 162 divided by 2 is 81 equals r to the 4th. Well, how do you get rid of the 4th? To get rid of that, just take the fourth root. This, as sometimes we call it, houseifies. So r equals, well, what times itself 4 times would give you 81? And that is 3. Well, this question doesn't ask for r. It asks for the geometric means. But now I know how to get from term to term. To get from 2 to that next term, I have to multiply by 3. So it'd be 6. Multiply by 3 again, and I get 18. Multiply by 3 again, and we get 54. Multiply by 3 again. Does it actually work out to be 162? Yes, it does. Now, did r have to be a nice number in this problem? Well, unfortunately, it didn't. It could have been 2/5. It could have been 1 1/2. Who knows? I chose one where it worked out fairly nice. Okay. So both times we did the means problem, we basically used the formula to do the work for us, but it was very helpful to write out the terms. Because a lot of people would have said, well, there's 3 geometric terms and I know one of them, there's only 4 terms total. Well, technically in this one, there's 5 terms total. We just have to find 3 of them. And that's where people will mess up on that.